So good day everyone. I am Sarah Vera M. Shabir and I'm happy to present my own unique geometric model entitled BoomSun Prism. So my geometric model looks like this. So my geometric model has 16 symmetries, both front and back. So for my front part, I have labeled it as A, B, C, D, E, F, G, H clockwise. And for my back side, I labeled it as 1, 2, 3, 4, 5, 6, 7, 8 counterclockwise. So let's go ahead and discuss what are the symbol they represent. So as you can see here, I have 8 to H letters and 1 to 8 numbers. And each symbol represents a unique symmetry or move. Let's begin with symbol A. So for the symbol A, I have the symmetry type identity, meaning no change or do nothing. So when we have the symbol A, meaning we will not do anything on our is the original if this is the original um this is the original model, then when we use the letter A, then it will be the same. And and for the next symbol, we have letter B, which has a symmetry type, 45-degree rotation, and the description is rotate. Hmm, This is a typo. This should be rotate 45-degree rotation counterclockwise. And then for letter C, this should be rotate 90-degree counterclockwise. And for letter D, we have rotate 135-degree counterclockwise. And for letter E, we have rotate 180 degrees counterclockwise. And for F, to rotate 225 counterclockwise. And for letter G, rotate 270-degree counterclockwise. And lastly, for letter H, 315-degree counterclockwise. So I'm very sorry for the typo error. Um, I haven't noticed that I haven't changed the numbers in here. Anyway, and for the number one, we're gonna flip it through vertical line. So as you can see, if this is the front, we're gonna flip it in here to go at this place or to this back space. And for number two, we have flip and rotate 45-degree clockwise. Number two, flip and rotate 90-degree clockwise. Number three, flip and rotate 135-degree clockwise. Number four, flip and rotate 135-degree clockwise. Number 5, flip and rotate 180-degree clockwise. Number 6, flip and rotate 225-degree clockwise. Number 7, flip and rotate 270-degree clockwise. And number 8, flip and rotate 315 clockwise. So let's take a look at the table that I have created from these movements. As you can see in here, I've colored the rows or the columns rather color orange, and for the columns color green. And as you can notice, there are elements that are shaded or in color red, meaning these are the identity element. And later on, we will learn more about this table, how this happened. Okay, so for example, I have B and then B star B. Remember earlier, B meaning rotate 45-degree counterclockwise. And if we're gonna go back to this original position, if this is letter B and if we're gonna rotate it 45-degree counterclockwise, we will have the letter C. So that is how the movements happen. So to identify or to show that the set of moves BS A, B, C, D, E, F, G, H, 1, 2, 3, 4, 5, 6, 7, 8 forms a group, we must verify that it satisfies the four group axioms under composition of symmetries. So for the first one is closure. And if we're going to look back to our table, all the resulting elements are in our set, which is BS. So meaning the set or the group forms or the set of moves form a closure. Next. So next, we need to verify that the table of results of the geometric model is associative. So to do that, we must rotate it by 180 degrees. So this is what I did. And to reach, or by inserting and interchanging rows and columns, the resulting elements on the flip table can be arranged like on the original table of results of the geometric model. Therefore, it is associative. So I want you to notice this table after I interchanged and after I insert and interchange rows and columns, it went back to the original position. So meaning it is associative. And last, and for the third, identity element. So as I've shown you earlier, the identity element is A because there's an intersection of the row and column on the table that was the same as the order of the elements on the outline of the table. So in here, so this is the identity element, meaning since our meaning this the identity element when we do this, we will go back to our original position. And also inverses, let's check if there exists an inverse for each element. There exists an inverse for each element rather. So for A is A, so let's go back again to the table. So for A, we have here A, and for B, we have H, C is G, D is F, F is E, G is C, and then H is A. And for 1 to 8, their inverses are themselves. So meaning, since there exists identity element for every row and column, that is A. Therefore, it has inverse elements for all. In conclusion, the geometric model shows a group structure because it satisfies the four conditions. So after this video, we have verified that the BoomSun prism form a group.